And we're live. Welcome to the Theories of Nothing. We're a community of nobodies discussing the nature of reality and truth. Please know there's nothing here to like and or subscribe to. And today we have Dr. Jason Glowney, who is a board certified internal medicine, emergency medicine, and sports medicine physician from Chicago, Illinois. He's a graduate of the University of Illinois at Chicago College of Medicine and completed a dual residency at the University of Illinois at Chicago in internal medicine and emergency medicine, and then a fellowship in sports medicine at the University of Colorado. He founded Boulder Biologics, a clinic specializing in orthopedic and medical biologics in Boulder, Colorado. Dr. Glowney has a Master of Science degree in Applied Mathematics from the University of Washington. His primary area of interest and research is mathematics, including the beauty of Lie groups, chaos theory, number theory, differential geometry, geometric algebra, and complex analysis. He is the author of the Arithmoi book series, a study of existence as a mathematical construct. So that's quite the resume. And I
Yeah,
hope I pronounced that well. Arithmi, I think, is the Greek pronunciation. Is that correct?
that's good. Yes, yes. Yeah, thanks. Great to be here with you, James.
Great. Yeah. So yeah, Jason, if you could give us a little bit more background as to how you got to write this book, why you're interested in a unifying theory, and yeah, that would be a great place to start. And at the same time, I would also like to know how much you are involved in ontological mathematics.
Sure, sure. Yeah, I think the initial impetus, I always liked math, even from a young age. And I think it's a thing that I kind of circled back to it a little bit later in life after med school. And yeah, just reading some philosophy about ontological mathematics. Probably David Bohm was kind of an inspiration as a physicist. And many people might not know Mike Hockney, some of the books that he wrote entitled like the God series. So it's kind of, reignited this interest in it. And so that's when I started to do math again, finish a master's in applied mathematics. And a
Hmm.
lot of the stuff that you learn in programs, they don't really revolve around the philosophy of mathematics or kind of some of the math that pertains to it in many ways. So a lot of it, especially in applied mathematics, it's a nice approach where you can kind of learn the skills to see something, to think about it abstractly and maybe put things together. So maybe a little bit different than pure mathematics, but there's a lot of overlap between the two subjects in many ways. So yeah, the goal with the ontological mathematics is to kind of look into what we say, like, yeah, the mathematics of existence, to kind of see what causes reality, to explain it, and define it mathematically. So
Hmm.
yeah, and the nice thing with mathematics is you're not limited by some we call it in mathematics a subgroup of a larger group. So when you're stuck in a subgroup like we are in reality in some ways, physically, that is, any experiment that you contrive, it's not going to see the whole. So yeah, the goal of all the mathematics is to define the whole, and then you can maybe know its parts. So physics looks at its parts from the standpoint of being in space time, but yeah, there's
Hmm.
a whole other kind of structure to it, or geometry, we like to say. And the goal of the book and the writing, it's really a series. This is the first book that will be released probably towards the end of April, but to show how something that's non-local, meaning outside of physical space-time, gives rise to phenomenon in space-time and the geometry itself. So to do that, yeah, you operate under certain criteria, like net zero, which means that to have a universe come from a singularity, we like to say, it's got to if it expands somewhere, it's got to contract in some other place. And if it's speeds up somewhere, it's got to slow down somewhere else. So you can take the number 0 and, translate that to 1 minus 1. But if they're separated, you can kind of create, a space on one side, and then we call it like an antiform on the other, where the two add to 0, but they're constructs mathematically in their own right then.
Okay, okay, that's great. There's so much to unpack. Earlier, you mentioned that mathematics sort of is a way to go beyond what physics kind of is limited to, which by definition it's limited to the physics of things. So if you're going to
Yes.
go outside of locality, then you need to use mathematics. So my question to you is, do you consider mathematics to be a primarily rational enterprise, whereas physics is purely empirical? Is that how you would categorize it?
Yeah, I think I could probably say a lot of physics is quite empirical, especially the experimentalists. So it seems like you can put them in two camps. One are the theorists who can think abstractly and look at things, and then the experimentalists. You look at like the Large Hadron Collider. Yeah, those are pure experimentalists typically, where they're dealing with phenomena in space time. So yeah, and you'll see two different thought processes between the two, where we hear all the time from some folks, if we can't see it, we don't believe it. So what that means, it's got to be real. And the collider is limited by relativity in terms of like the speeds that they can collide particles together with. So it's quite a bit different. But yeah, there's always that question from where it came, and so. Yeah, just the mind can kind of take you there, and with appropriate thought and appropriate mathematics, you can start to see, what gave rise to this. And yeah, so I think it introduces the math is rigorous as it comes, but that's important. And you have to be able to explain all of physics, and hopefully through that process, you're kind of advancing physics in many ways for those who can kind of embrace it, I guess you'd say. I think we kind of write and think about this stuff. It might be for the next generation in many ways, where I think some people are ingrained in how they were in how they think and how they do math. But a lot of physics will take math, borrow it from all over the place, and just it's like a patchwork of something that seems to work. But it's I think it's important to see the whole structure, and then you could really understand its parts.
Yeah, so that's why I got interested in what Alex, who's our mutual connection, right? He
Hmm.
was explaining to me the benefits of ontological mathematics, which is, and it's strange because I'm still trying to understand where where the communities lie. Like you said, there's a couple of camps in physics. You have theoretical physics, and then you have just physics, experiment-based physics. And then everything is based on mathematics. I mean, at the end of the day, they have to make their measurements somehow, and they're using mathematics. And of course, mathematics itself is based on logic and a priori axioms and things like that.
Hmm.
So it would stand to reason that if physics and theoretical physics uses mathematics, and mathematics is accepted as a tool of truth, that then if mathematics can go beyond physics, that really is the next question. Can it go beyond physics, and does it? Because I think that's where things start to get a little bit more difficult to prove. Because, but that, again, how do you prove that mathematics can tell you something about the nature of physics in a way that you can't see it? You just have to go based on the assumption that logic is a priori and that a priori truths are true. So, how do you respond to that kind of, let's say, darker area? Because as a metaphysician, that's what I do. We all we can rely on is a priori truths, and say, well, look, all we can use is logic. But ontological mathematics seems to be, it might be the bridge between metaphysics and theoretical physics, and that's why I'm excited. I'm curious about ontological mathematics. So how do you prove that it can go beyond physics to describe physics in a way?
Sure. I think you can basically, it looks at the singularity, and I think one of the things in physics is what they consider a point particle is the electron, for instance. The electron's interesting because it's there's classical physics, which is kind of physics that was occurring before kind of the quantum mechanics revolution, but a point particle basically has got zero length, and so it's interesting because through quantum mechanics they realized that the electron has its own intrinsic spin, and so it has momentum then. But classically, momentum requires a distance from some center point with which it rotates about, and so they saw this that there is a momentum with the electron, even though they consider it kind of a zero-dimensional point. Mathematically, it's interesting because the zero-dimensional point actually has a volume of 1, so it's one of these things that it acts like a bridge between two infinities, I like to say. One is the infinity from 0 to 1, which has just as much room in it really as the infinity from 1 to infinity the other way. So that's the kind of the dichotomy between the two. And when I mentioned that for something that extends, something contracts. The contraction happens between 1 and 0. The extension happens between 1 and infinity. You multiply the two when they're paired by this net zero principle, and they're going to equal 1, which is the volume of the zero dimensional point. So that's kind of the bridge there. And a lot of quantum physics is actually based on what's occurring between that 0 and 1 point. And so if you can show what it actually is mathematically, in physics they should accept it when they see that everything that stems from it leads to their physics that they're describing in a geometric way, where it's actually quite a bit easier to digest and to actually see what's occurring. That's how you kind of make the crossroads there. In terms of a bridge from ontological mathematics to metaphysics, I think it's there also because you're describing something that's outside of the quote unquote reality or the physical reality. And so you're showing that something that can't be seen physically in ways that we see, kind of real phenomenon. That kind of gives you this metaphysical link that shows that there is something besides this physical construct, or people like to say the meat jacket we're walking around in. So it's that's kind of where the link is. And so I think from a standpoint, there's a lot of really intuitive folks out there who do metaphysics and ontological mathematics, but I think some of the limitations is they try to do too much with too little, where they operate under a simple assumption by using one mathematical construct and trying to explain everything. There's this thing where it's got to keep flowing and things have to connect, and different geometries have to connect as well. So that's kind of the thing that the books are looking to describe, with mathematics, and to kind of show how everything flows from one thing to the other in that way. So I lost you a little bit, but maybe I'll just keep talking.
Sorry, my mic was muted. So,
Gotcha.
again, just for the viewers, I'm in the hills of Colombia, so the internet kind of cuts out sometimes. Okay, so it's interesting that you were talking about the bridge between metaphysics and ontological mathematics, and to me, how they're bridged really is language at this point, because, like you said, there's a supra-physical reality, so it goes beyond the space-time construct, but that is still what in philosophy we call existence. If you're talking about information or possibility spaces, as George Ellis uses like concept, these possibility spaces aren't physical, but they are a form of reality. So in ontological mathematics, how do you describe that supra-physical reality? If it's non-physical, Is it nothingness? Is it void? What is zero in the eyes of ontological mathematics, and then in your own conceptual view of it as well?
Sure. I mean, I think I approach zero quite a bit differently than maybe some might, but yeah, just the ontological mathematics would see this as basically it's kind of the domain of the mind in a way, where it's non-physical, but it's conscious, it's in motion, it's not subject to the time construct like we know in space time itself, but it's just as alive and real as anything in the physical realm. And further, it gives rise to the physical realm. So it's this thing that always exists. And so in philosophy and in mathematics and physics, in a way, there's always thought about causality and what causes this. And if this happened, it makes this happen. And I think when you go deeper and deeper, it's like, well, what causes mind and what causes this space that's non-local and kind of almost at the what we say like the kernel of ontological mathematics. And then philosophically, you arrive at the conclusion it's uncaused. So it's always been, it's eternal. So that's kind of that's where you get into this thing where you do have to really think hard and long about what it means. And I think sometimes you see the mathematics, and to process it philosophically, it takes time. But I
Yeah.
think.
So I'm going to interject there because there seems to be a way that you have to think about it in a dual manner, whereas you think about things in terms of infinities, and then you can think about things in terms of eternity. And
Mhm.
eternity seems to be that static, always, non-moving, non-spatial temporal reality out of which the reality of infinity emerges. Because infinity seems to imply causality, right? We have one to two, two to three, and so on. So one thing causes the other. And so the would you say that infinity is purely restrained or just a physical construct thing, or does it go beyond? And is eternity infinite in some way? You know?
Yeah, I think it's like it probably will depend on changing the viewpoint of what time is. And I think the difference between time and space time, and some passage of events occurring in just in the 0 point, it's a calculative time versus geometrically in space time, it's based on hyperbolic geometry, which is different than spherical geometry, where it's it kind of it's a curve that opens up and extends, from right or to the left. And if you remember high school geometry, maybe you recall your hyperbolic curves. But we have some images where we can kind of show what it looks like. But not only does net zero apply to just the numbers, but also to the geometry as well. And a lot of it is based on light, and mathematically going into describing what light is well beyond just the waves from electromagnetic phenomenon really helps to kind of put it together to see what it is. But I think that math doesn't make mistakes. We like to say the universe doesn't make mistakes. It's optimized in that way. So but mathematical forms come together and form a product. They don't take a dump like your computer might from time to time. It just keeps going. If it didn't, it all falls apart. And so I think that just that say two mathematical forms make a product together, that's something that makes a change happen. So it's not like the time construct that physics describes in that regard. It's similar because there is a causality to it, but just when you dig deeper and you ask those questions, where did that come from? That's when you're kind of left with the response that it's uncaused, and
Yeah.
everything seems cyclic in many ways. Like here physically we see the day goes by, sun rises again. We rotate around the sun once a year, and then same thing where universe is cyclic also. And yeah, so that's the interplay between kind of the infinities in a way. And with infinities, there's several different infinities, and George Cantor was one that showed that some are countable, some are uncountable. And then the infinities that we deal with in Arithmoi is kind of the harmonic series. And the offset of the harmonic series is the integers. So harmonic series is 1 plus 1/2 plus 1/3 plus 1/4. The numbers get smaller and smaller, and at first glance you think that this thing's got to converge to some value, but it doesn't. It keeps it goes off to infinity, but very slowly. And then the integers, yeah, they blow up pretty quickly. But for example, the integers create expansion into the space-time that's created in some event like the Big Bang, where the singularity expands itself. But then the harmonic series is this contracting space, then, where that's from the 1 to the 0 where that kind of occurs. If you dig deeper and you look at harmonics and harmonic logarithms, they're called, there's these other spaces out there that actually are formed from geometric spaces, logarithmic spaces, and it's pretty amazing to see. But these things all interconnect with kind of the physical geometry also. And so there's more than just 0. It's 0 is alive and doing a lot more than we typically would give it credit for in many ways. So these things are churning, they're interconnected, they're interrelated, and they're interdependent in many ways too. So but yeah, from the ontological mathematics standpoint, the mind creates everything. And we like to say that we all age, and we all physically have some manifest form of some degeneration somehow. But the mind doesn't sense age like the body does. And so that's a thing where you can start to think, well, where is consciousness really located? It's not a physical construct where it's almost like this. It's not bound by the subspace. And what we see is that light operates at a different level, where it operates in what we call the angle space or the phase space. And I'll discuss this a little bit more because it might not make too much sense what I'm saying here. But
yeah, but before you do, so I just want to start to bring into some that can't, because they keep going towards 0 or towards infinity very, very slowly. So I also want to start to draw some parallels between mathematics and physics, because I was reading, there's a book called Zero, The Biography of a Dangerous Idea. It's a fantastic book. Charles Zeif, the guy who wrote it, really starts to explain how we keep running into 0 and infinity in mathematics and in physics. And you mentioned light as well. So he was discussing in one of his chapters the Casimir effect, which is basically the wavelength, as it gets smaller and smaller, there's an increasing amount of energy in it, and that this goes to infinity. And so the connection between 0 and infinity is something that seems to be inescapable. But what you were describing there with not the integers, but the what was the opposite?
Harmonic series.
Yeah, the harmonic series, is that. So basically, I'm trying to push you towards this question, if I can make it simple. Do you believe that we can divide by 0?
I guess it depends on how you construct the question in many ways. So I think if it's logical, yes, you can in many ways. And so, yeah, I think that if it's, to give that credence, I think that if you, progress the mathematics and show what it really is, you can. And there is like an example in the book where actually light actually creates the Dirac delta function, which is in physics it's very interesting, where there's been debate about whether it exists or not, but it's an impulse that is infinitely long, but its width is 0. And what is its value? Its area, you so to say, it's 1.
Yeah.
So that's that's dividing 1 by 0 in that way. But yeah, light is kind of there is a Dirac delta function that light creates, and mathematically we call it, it's in the asymptotic region, which means that it's a region that a space-time almost like converges to at infinity. But like in mathematics, we always talk about determinants, and basically what those are is you have two vectors that say they're orthogonal like this. A determinant is the area between the two vectors that's formed. So if they're exactly orthogonal and the same length, it'll form a square. If you go up in dimensions, it'll form a cube. But the Dirac delta is actually formed by vectors spinning around light in that way. It's as space expands, it's getting smaller and smaller, but longer and longer. So that's your proverbial 1 divided by 0.
Hey, Jason.
Yeah. Okay. I was just
Sorry.
going
Oh
to
my
text
God.
you.
It's like perfect timing. I should never set these meetings while I'm in the mountains. I should just anyway. The my phone's internet is back on, so that seems to be stronger. I think we won't have any more problems.
Okay.
All right. I'll reiterate. This is the big question, like the question I really had. Um, if 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 there are instances where you can divide by 0 in physics, and we have this proven, and in mathematics, does that mean then that 0 does equate infinity? Is that a proof that the two are equivocated?
I guess it depends. Like if you're taking 1 divided by 0 equals infinity, yeah, I think in certain instances, like like harmonics and other things, I think it is valid. There's in the book there's a proof that's offered that shows that it is valid, and the proof is legitimized because there's cancellation of terms that makes that the case. So yeah, I think it's a little bit of a loaded subject because you have to really well define what you're describing as your 1 and your 0. And so, but I think it's a very interesting and valid point. And I think to further that, there's infinities that are quite manageable, and the harmonic series is one of them. And harmonic series it's important because quantized things in physics are basically a result of what we're talking about, this net zero principle, where they come in discrete amounts, and so does expansion. If you expand the contraction, that's what's causing the quantization of energy and other things in physics. But yeah, so the harmonic series is really involved in that, and you can look at things like the Planck's law, which relates to black body radiation. That's if you dig a little bit deeper, all the harmonics start to pop out of there, the harmonic series as well. In mathematics, it goes well beyond the harmonic series, and everyone's heard of the Riemann hypothesis, where it's called the Riemann zeta function. But basically, it's the harmonic series, but the denominator in the series is something that's not just equal to 1. So it can take a complex number value. Or it can be something like the denominator to the power of 2. So instead of 1, 1/2, 1/3, 1/4, if you take zeta 2, that's 1, 1/4, 1/8, and so it can change that way. So they're integral parts of analysis, but when you see physics and the equations that actually work, that are meaningful and like I say, beautiful, harmonics are written all over them. And if you can take something in physics that they use, mathematically, and see that, it's good physics. There's a lot of physics that's, like I said, maybe it's a piecemeal of things that just seem to work. But yeah, so I think it's like defining what you're saying is the infinity is really important. So the harmonic series that leads to many other things revolving around logarithms and other things like that too. So like a lot of the book is based on something we call Lie theory, and Lie theory is basically its groups. There's a Lie algebra, which is kind of like in like a Fourier analysis. These groups actually have almost like certain essences to them that explain almost all of their properties once you do exponentiate these things. And so it's just like when you see a superpositioning of many waves, just through Fourier analysis and the transform, you could see that it's three different spikes and waves that create this pretty intricate pattern of wave phenomenon. The same thing exists in groups and the spaces that they create and the geometry that they create. It's just at a higher dimensional level. And so these things are all related to the harmonic series. They're all related to the logarithmic functions. And so they're all interconnected in that way. So, and it kind of boils down to what we see in the extended space is actually occurring on the surface of the singularity. And so this is like black hole dynamics, where, like you mentioned before, what happens to information when it goes into the black hole. And then, it's kind of spread over the surface. They like to say with physics, and what they're saying, it's they're actually describing a thing that's occurring from Lie theory. And in the book, we extend something called the tangent space. That's like the equivalent of like the Fourier transform in like the differential geometry meaning. But we extend it to cover the whole surface of the singularity, and you could see anything that's happening in some extended space. It's imprinted on the singularity itself. So that's the 0 point. That's the zero that people are describing. And so dependent on your approach to what zero is, if you define it as the singularity, a lot of stuff's going on. And it's something that's manageable, though, actually, to consider division. When you get to higher dimensional spaces, just the kind of the algebraic way to put one number on top and one below, it doesn't necessarily hold anymore, because you actually consider the inverse of like these higher dimensional forms in many cases. So it turns into a product, and it's not just 1 divided by 0 anymore. So that's when the products take on much more meaning and give you much more information. And that's when you can also see that the proverbial 1 times 0 actually is an infinity, or sometimes does it equal something else potentially. But so point is, like, what's your infinity? If it's some just blown up infinity that goes to infinity immediately, it's not tameable in a way. That's where you maybe don't get the meaningful information. And there are many infinities there that are quite meaningful, though, where they're maybe countable, as Cantor would say, but those are the ones that seem to play out in the physical sense, and the ones that maybe we're potentially more interested in knowing more about.
Okay, so I'm gonna have to do like a bit of a represent the layman here. I have almost no grasp on a lot of the things you're talking about, like the transform and the hypothesis you mentioned, Lehman. These are things that go way beyond a lot of most people. So here's what I'm trying to do, and I'm curious if this is something that you're interested in doing. But like your book, I'm sure, is probably geared towards people who have a substantial amount of knowledge in mathematics. But how is it possible to translate it in not necessarily in terms that are, because if you would have to break things down to their fundamentals, you're basically having to teach people mathematics, and that's not the goal. But is there a way to translate the mathematics that you work on into manageable terms for philosophers and for physicists, and for, because you see what I mean? Like,
Mm-hmm.
there seems to be a lack there, and that's what I'm trying to fill, like, void. Whereas, you could take a philosopher who, well, if a philosopher were to be able to understand the implications to a certain degree of your mathematics, do you think they would be able to translate it in linguistic terms or logical terms that could bring a sort of greater understanding to regular people, you know?
Sure. I think that's one of the goals is, yeah, I think to first emphasis is to be rigorous and
Mhm.
validate and back up what you're saying through
Exactly.
mathematics. That's like what we say cohesive and makes sense.
Mhm.
But the interpretation is just as important after that, where yeah, you can kind of spread the knowledge through yeah, through language and philosophical terms and metaphysical terms, and so that's just as important. The
Yeah,
book basically starts out with the assumption that the reader does have some prerequisite knowledge, which will include things like it is geared towards the at least the undergrad in mathematics and or physics, where they've taken linear algebra and calculus and have a good handle on that. But it is a gentle introduction, and it's what we call like a mathematical monologue.
mhm,
I have a friend, Mika Pierrot. He's in Quebec, but he calls it a mathematical grimoire in a way. So, but it takes the reader through all of the mathematical thought processes. It errs on the side of saying too much and say instead of saying too little. I think mathematicians are guilty of putting everything in some semantics that loses the reader immediately. They like to come up with symbols that are hard to decipher or hard to remember. But we try to change that where it's mathematical, so there's no getting around to it. You
yeah.
need to know math to really embrace it at that level. But yes, I think one of the focuses will be to, yeah, just to give the overview and but have kind of relate the deep meaning to what it actually is saying, and that's really important, and it is a priority for kind of what we want to do in the future.
Very good. Yeah, because the way I see it and the way that you speak, here's how I intuitively grasp what you're talking about. And it's that mathematics seems to provide resolution to pure axioms so the question is, the more that you can describe and the more information that any given mathematical equation can give you, does that higher resolution really support, or does it do the opposite? Does it make it uh, more obscure that the underlying truth that it's trying to describe, right? Like, for example, it seems that, and Michio Kaku kind of echoed this a couple of times throughout his interviews, that technically the most beautiful, the most concise, and the most accurate descriptors of reality happen to be equations that are like an inch long.
Hmm.
So the question is, so like E equals mc squared it's a brilliant equation that can be understood by almost anyone,
Hmm.
and the reason for that is precisely because of its capability to reduce complexity to an axiom. So and if you have the ability or the fortune to understand mathematics and the desire to, then you can start to look into the complexities that emerge, and those things just reinforce with higher resolution the truth that you already knew through a certain axiom. So you know what I mean? There seems to be like the human mind seems to function in a way where it requires experience of things to have a greater view of reality. So it's kind of like I could tell you that love is the answer, and that might have a meaning, right,
Yeah.
to you, but then you'd have to experience how profound that is to really know, how much more complex that truth is. So that being said, do you do that in your book? Is that something that you're working on, or?
Yeah, I think a lot of things like reducing it to a smaller form that's quite easy to grasp and digest. It's helpful. There are many forms that are reduced almost to a degree that's way beyond what they should be. When you start to lose clarity and
Mhm.
what the true meaning becomes blurred, that's when it's maybe problematic, or that's when you potentially lose important insights into what it means. But
Mhm.
yeah, I think that Michio Kaku, it's like equals MC squared. Like, yeah, everyone knows that one. it's it's one of these things where it's recognizable in that way. But yeah, I think the book tries to simplify things, but then to also expand on things that look simple to show just how much dynamics there is and how deep it is. And so, and I think that's that's an important thing where lots of times it's lost with mathematicians and physicists, where the reductionism is sometimes a problem, where you lose grasp on where you are and where you're going. To
Yeah.
I think the major thing in the book, it shows the geometric structure, which is where this is and where that is, how they interact, and that's the really helpful part of it. Where it's I'm not sure if you've heard of Cole Fury, where she's done a lot of work in the octonions, which is kind of a higher dimensional imaginary mathematical structure group, but the octonians are hard to grasp, but because they don't make sense to many people, just because they're thinking in a 3D spatial way, potentially with time or 4D, but
Yeah.
they're 8-dimensional. But she kind of is taking the foray into this realm. This is a little bit similar, where it is higher dimensional, but it can be related as a projective geometry, where meaning you see shadows of the higher dimensions and how they manifest in your own existence, or how your brain processes things. So that's an important part. But I think what's lacking in physics and other explanations are the geometry of how it all interconnects. And so the interconnectedness, it simplifies things. Where I'm sure if you've seen the standard model equation, it's like 3 pages long, and it's like, oh my gosh, I don't know what this is when it's expanded. But I think it's a big simplification in that way, where it becomes digestible, from just the intellect, when you could put it together that way. So in
I,
the basic,
I agree. So just to reiterate what you're saying, there seems to be, there's a necessity for balance between simplicity and complexity. Too simple, you lose the meaning. Too complex, you also lose the meaning, because there's too much information to grasp. So there seems to be the necessity for some kind of almost like a window or like a matryoshka doll that allows you to enter this truth in a sequential manner, in a way. Like, so you open the first door, you can see the space, then you open the second door, you can see the shape, and then so on in the form, and you start to include more and more um, complexity. And so the idea of geometry, to me, might be like the connection that, or what allows for that balance between simplicity and complexity. Now, in my own work, and also there's someone else in this community, his name's Brandon. He looks at things through geometry, specifically because geometry seems to have there's a connection between mathematics and geometry, and geometry, of course, is the basis for physics. So it's kind of like the linchpin between the two. And so maybe if we have a geometric, and maybe that's why in history there are so many geometric shapes that are universal, right? Like the triangle, the pyramid,
exactly.
tetrahedron, or the circle. These things are deeply meaningful, and you know, is there in your view? So I'm starting to take it away from the technicalities, and I want to get more towards the meaning of everything. But like, do you believe that today there is a necessity for people no longer to just invest their intuition in the symbols that because I'm going to contextualize what I'm about to say first. Alex, who is our mutual connection, he believes that we need to clarify the logos and then allow for a mythos to emerge. So the idea that people don't just worship the pyramid without knowing what it means anymore. So that mythos seems to have been something in the past that was sufficient, but people didn't require the logos. That was reserved for the priests and the shamans and the whatever, right? The people who were authorized to hold that sacred knowledge.
Sure.
So Pythagoras, things like that, sacred geometry, and so on. And so, do you believe that today, now, the that geometry and mathematics and ontological mathematics, more precisely, might be one of those things that allows everyone to also have the logos? And do you believe that it's necessary for everyone today to have the logos as well as the mythos?
Sure. I mean, I think it's like, just having equity in terms of what you can and can't do. It's important, and I think just with the ability to share ideas on the internet and things, I think it's widely available to many people. I think from my standpoint, time's my issue, and with two young kids and a family. I get up at 2 o'clock every morning to write, and then go to work, come back, hang out with the kids, and so you have to carve that time out. So it's like the prioritization of this is important, and you don't buy enlightenment in a can off the shelf at the store. You have to work at it, and so I think
Yeah.
that's the thing where those folks who are actually open and willing to do that and willing to invest the time, they have access. They should have access to the logos because they're
Mhm.
deserving of it in that regard. So I think there's many approaches to quote unquote enlightening thought or enlightenment itself, but I think from the ontological mathematics standpoint, math is the prime mover in that way, and math is there's bad math, and there's bad philosophy too, and I think we both know that, but yeah, I think gone is that day where logos shouldn't be used as something that's controls other people, where someone is of a higher prestige level, so only they have access to it. I don't think that should be the case.
Mhm.
I think you lose so many people who have like incredible potential to contribute that way, and so I think the more the better. I think on the flip side, you'll run across folks who are very biased to their own opinions and their own theories, and if it doesn't jive with what they're saying or what they think, they immediately dismiss it. But I think
Okay.
that's a problem too.
And so everything you're saying is very exciting to me, and I have to. It leads me to thanking you for speaking to me, because, like you said, if others can contribute in ways that are, let's say, useful, to me there seems to be a singularity happening in human consciousness, like you said, with the internet, people having access to this information, and then people like myself who try to bridge. Like, I only have a certain limited knowledge of mathematics, physics, so very limited, in fact. uh, all I have, like, a contribution to make, or that I'm trying to, is to try to understand it and translate it into logical terms as
Mhm.
simplistically as possible. So, recently, will give you a bit of background on me. The reason I started this whole community and channel and everything is because I was part of the Theories of Everything community,
Mhm.
which is a fantastic channel where, I don't know if you're aware of it, but
Yep.
Kurt Jaimungal, he interviews public intellectuals, and they're incredibly prestigious. They're incredibly intelligent. A lot of what they say sometimes goes over people's heads, but at the end of the day, there's a lot of people that try to learn and try to understand what they have to say, and these are their idols. And I believe that ultimately, can someone in the streets apply even just the most simplified, reduced sort of truth of any kind of these public intellectuals? It seems to me that in the past, a lot of figures like Christ and Buddha and whatever, they took these beautiful, enlightened truths and allowed for many people to understand it on their level. Now,
Mhm.
whether you want to consider that as a hierarchy or not doesn't really matter. You can look at it in a lateral manner as well. But, like, if everyone can apply truths or axioms in their own way, like you said, there might be sort of a contribution that is valid insofar as people are participating in the same shared reality and they are all on the same page. That is a sort of a unifying theory. That's why, to me, I felt like, okay, well, the theories of nothing might be able to bridge the metaphysicians with the physicians, the ontological mathematics peeps, like the esoterics, with the rigorous academic mathematicians and so on, can there be more unity between people's ability to conceive of reality in different ways? So, and ironically, the things keep on telling me that yes, it is possible. For example, I had a gentleman, I won't name him, but I still have to speak to him. He's quite busy. He's an engineer, but also has a mathematics background. He saw my video. I entered the PACE 1 contest in the Theories of Everything community. And my equation is called the infinity limited, and it's based on my theory. So it's based on something called coexistence theory, and the idea that everything is paradoxical in nature in a way, or at the very least that if you want to arrive at an understanding and a logical proof, a rigorous logical proof of reality, you're necessarily going to have to observe consciousness, and consciousness, see the experience that you have in consciousness when you think about things like infinity and division by zero, and they're paradoxical. So if you observe the paradox, or the experience of the paradox itself within consciousness, that can lead to a higher understanding of what's going on, and the complexity of everything. So anyway, this guy saw this video and then sent me a message congratulating me. I'm like, I have no clue what he's talking about, but he was congratulating me on a rigorous logical proof for what he is working on as a mathematical proof. He said that my equation, which is barely an equation, I mean, it's not even mathematical in a way. I just use it's kind of like formal logic almost. It's just symbols that represent ideas. But and he says that he's working on solving results of the division by zero problem, if you want to call it a problem. And I don't even know, like I'm just starting to try to understand what that means. Like, is it that the division by zero creates absurd results in mathematics, but that those results can be solved in some way that brings us utility, or at least some kind of truth? I don't know. I'm just beginning to try to know. That's why I love speaking to people like yourself. So first off, I want to understand like the mathematical translation of my logical sort of statement. My logical statement is, that there is a transcendent truth, there is a unified truth, and you can achieve it through a paradox. But how would that look like mathematically, and can that be proven mathematically? And if this guy comes out and says, yeah, like you have a successful logical proof for what I'm working on in the mathematical side, then it seems to me that, and this is why I have a diamond in the logo of my thing. I call it the unity diamond. There seems to be that which we are describing, the spirituality, the transcendent, the zero, the superposition, the potential, whatever you want to call it, that which we're having such a hard time describing. And then at the top, and then you have mathematics, physics, and language. And see, if we bring these three together, can they translate into each other to achieve a perfect description of that zero, that state, that truth? And so to me, I always seek to describe the objective reality in such a way that we all necessarily have to interpret it the same way with our subjectivity.
Sure.
So it allows for, do you understand what I mean? Like, even though we are all sort of chained to having a subjective interpretation, that there might be a way to describe reality in such a way that we all interpret the same. There's no other way to interpret it. And there is true objectivity there. It's an a priori objective truth, just like logic. No one debates logic, and if they do, well, then they step into my world, which is paradoxical logic. You say no, logic isn't true. Well, by saying that, you're making a truth statement, and that's why I work at the level of paradoxes. So I don't know where I was going with that. I'm just kind of passionately ranting, but
no, I understand. I think it's valid points. Like, can you interconnect different disciplines that currently maybe seem pretty different, really, and they've kind of traveled away from one another in many ways. I think there was a point in the past where religion and science were quite connected, and it's gone now. I think it's if anything, maybe a lot of religions need a pretty serious update in terms of what where we are mathematically, scientifically, logically, and when you're fed illogic, it's that's why people turn away from it now. But I think that shouldn't make you lose sight of zero and what consciousness is and how it science can't explain consciousness at all. I mean, there's some folks who are looking at it with more intent, but it's limited in that way. And so, but I think that the proverbial division by zero, I think the singularity is zero, and so I think it is a potential link between many different disciplines in that way. And you were talking about it before, but I think that it needs to be translated in a way where it's like approachable to everyone who's actually interested in it. And I think it can be done. And I do it in the book. I feel like I'm just an oddball where I feel more comfortable writing math. It takes me longer to write words on a paper than to write pages and pages of equations. So but it's just the way I'm wired in that way. But yeah, there is a link there, and that's the emphasis where it can be translated to those individuals who are wanting to know more about it. And I think that it's important to have a community where it's like a group think type of thing. It's one person can't do it all. Some people maybe generate ideas and things, and others, kind of try to translate it so they can relate it to other folks, and that, so you almost form like this intellectual network of exchange of ideas and things. And so that's really important. But and to your point about where you were coming up with like a logical functional, where that's what math is. And it's surprising where, there's mathematics is, there's creativity to it. There's intuitive, you have to be intuitive in some ways too, especially if you're trying to define new math. It's like, it's a thing that you have to think differently. And, it doesn't work to think, like a robot. I don't think you're going to come up with too many bright ideas. Maybe you'll process old theories quite well, but yeah, so there's a flow to it, and it's just humans have a way to describe it and put it on the page. But it's like you said before, what it truly boils down to, it's things moving, it's shapes moving in different areas. It's this thing where if you can visualize it that way, and basically like the way it's described in the book, it's it's in math or geometry or group theory, we call it like dihedral groups. So dihedral group is takes a polygon, and so the regular polygon in particular, which is like the three-gon, for instance, it's the equilateral triangle. So it looks at how it moves in not just real space, but in complex space. And that forms the foundation of which where everything flows from in many ways. And so, it takes a really simple idea and then runs with it. The idea people can grasp. So it's kind of at this level where it's approachable to everyone. But just the complexity of the dynamics that it can give rise to explains kind of what reality can turn into, and what we see and what we envision, even like the biologics of reality and existence. So yeah, it's a thing where there's very simple ideas, but to see them through, it's really to kind of show what they're capable of doing in that way. But yeah, so I think as a mathematician or a physicist or a philosopher, metaphysician, it's it's like developing that ability to know when to linger, and this is an intuitive thing. Know when this idea is important, and you feel like, hey, there's something still here, I'm going to stick around, or knowing when, hey, this is a mess, man, I'm getting out of here, it's not worth it. So because you can waste a lot of time. Maybe the proverbial example is Einstein trying to link gravity with quantum mechanics. It's like spent the years of his life towards the end just trying to do that, and it was difficult. But another point to make too about dividing by zero, it's it's this thing where sometimes you're only looking at one side of the function. So say there's a curve, it's on a positive axis, the other part of it's on the negative axis. Are you just looking at the positive part of it? And just in terms of like prime number theory, for instance, a lot of the headway came through like Bernard Riemann, who was able to transform it. So by that, I mean that he changed the equation where it still had all of its essence, but you shifted it or rotated it in a different way where it actually made sense with the questions that were being asked. And so it's, that's something that you can do mathematically. And so taking these different approaches with transformations and things, it becomes possible. So to approach an infinity, sometimes it goes off to infinity one way, but say if you rotate it on the graph so that curve hits some axis somewhere, you can actually get much more meaningful information from it that way. So so it's like this thing where you can be quite dynamic with your approach, and you can start to answer those questions. I think when you say 1 divided by 0, if you define what you're using, then it becomes possible. But 1 divided by 0, just as the integers, it's tough to make to explain that, because it's in a way like a simplification of some of the deeper structures and mathematical constructs that are out there that you have the ability to do that with potentially.
Okay, so that's a good segue into what kind of mathematics then would you suggest someone to start like learning that's absolutely necessary to start to begin to understand these kinds of mathematics that you're working with, the ontological kind? Um,
Sure.
yeah.
Yeah, I think kind of basics. Algebra, trigonometry, geometry. Those are the ones that you study in in high school, middle school. I think to go to the university level, it's going to be the kind of the multivariate calculus, differential equations, linear algebra. I think when you have like this, just this appreciation for philosophy and the philosophy of mathematics and logic, you see the teaching and what you're reading in a much different way, which is really good because you start to make the connections.
Yeah.
Yeah.
And so to appreciate those fields precisely, that's where mythos comes in, storytelling. See,
Mhm.
in if I was horrible in mathematics in school, and I still am in many ways. I can barely count. So but the irony is that I have a predisposition for thinking with logical terms. So if someone had given me the story, kind of like Feynman, I'm basically echoing Richard Feynman here, right? Like if you explain to people like why you're learning calculus and what calculus allows you to do, then it's like, oh my God, I can put a projectile on another planet because of
Yeah.
calculus, and that's what calculus does. And then, you start to explain things in ways that have utility, and then I think people are more inspired to learn these fields. But like to just say, look, you'll understand reality if you learn calculus and algebra, people are like, well, they just see the symbols and all the complex stuff, and they think, I get the same thing with my students. They say like, oh, philosophy, it's so complicated. You have all these complex terms, and it's like, okay, like you said earlier, there's good philosophy, there's bad philosophy. There are a lot of terms that are standardized that all they provide, these terms, is to take an idea that takes 2 sentences to say and to just have a word for it. So once you learn and you unpack these terms, it's not actually that complicated at all. And you start to be able to have like tangible bricks that you can move around and start building bigger and better ideas with. So I'm sure that mathematics is the same in a manner. Um, it's just that there's a lot more terms. There's a lot more. It's like the degree or the axis, or like the parameters of mathematics might even extend philosophy. I think it does extend philosophy, which is why it's so fascinating to me. Like, if you want to dig around and understand, what's happening at the edges of the expanding universe, you're not going to do that. Well, you can do it with philosophy to a certain degree, but at some point you're going to need mathematics, right?
Yeah.
Um, So that being said, like, is there the opportunity for a new field, do you think, that sort of combines philosophy, mathematics, and physics in such a way that it's geared towards people understanding reality in a meaningful way?
Sure. I mean, I think historically it was metaphysics, but I think that having a basis or like an entry level point for an interested person to kind of come into that, I think redefining the metaphysics to what it was originally, I think is maybe a way to get there. But yeah, I think it's like just lost in the semantics of the terminology. And, a lot of
Mhm.
this is like some ego based. And sometimes you think maybe they only want certain people to understand this. And that's why they make it so veiled and difficult to decipher. So it's one thing where it's they call it the expert blind spot, where you deal with this all day, every day. It's like, what it is, but you lose sight of, I need to explain this to someone and make it, interpretable to, kind of someone with, the prerequisite knowledge for what you're trying to describe. And lots of times that doesn't happen. You go to look at math books, you're like, man, this is horrible. It's like your mind shuts off immediately when it sees all that stuff. So,
Yeah.
but yeah, I think,
But it
that's
depends on the intention, right? Like, I mean, if you're
sure.
writing it for others to peer review it, then that's understandable. But if
Yeah.
your desire really is to inspire others, to translate your ideas for others, then so
Mm,
I guess that's the question to you. Are you with your book and um with your I see I don't we haven't even discussed, like, is this a theory of everything? Like, do you have are you working on a unification through your mathematics and all this? But and if so, are you just trying to peer review it with others, or is this geared towards the larger public? And what are your intentions?
sure. I think it's somewhere in between. I think with like literature and peer-reviewed journals, I think the limitation is lots of times there's a restriction in terms of the length of the paper. There's no way that you can say what you want to say with this type of subject matter to the depth that is going to be comprehensive in a way. And so that's why I kind of elected to do a mathematical monologue in a way, where the first book is just about 500 pages. And that's how long it takes to describe the ideas and to describe them well enough where they're logical, they fit together, and they're also you can follow along, and then just kind of see all the the transitions from spaces and how it all connects. And it doesn't boil down to one simple page, that explains it all in that way. I think you can put the ideas in a very concise way, like in language, but it's just a superficial view of it in that way. So that's why I kind of the book form is a nice way. And what's also nice now is you can self-publish. And I think the one thing it's to me, it's like knowledge that's always been there. It's not mine. And no one owns it in that way. So when you use a publisher, they own the material in that way. And having rights to use it, we want to be able to, kind of have this as like a group source type of thing where it's available to anyone who wants to see it. And so I think that's important to, keep it where it belongs, just in, kind of available to anyone and everyone, who wants to look at it. So, but yeah, I think just to explain it to the point where you can be convincing, yeah, it takes time. And, just there's no hiding anything, nothing's swept under the rug. Nothing's
Mhm.
like, hey, I just took this from out of nowhere because it works. It's got to be logical, and to be logical, you have to explain it in a way that everyone can follow who's just kind of at that level. And I think a lot of folks that I know want to be able to explain it to other people, and they can. There's a lot of explanation in there too about what it means and how to interpret. So someone can get the book and then just read the paragraphs, and then they have an understanding and look at the pictures. Where to me, pictures is a way to really envision it and get it to sink in, because there's a lot of visual learners. I know that's kind of how I see things, like just how does it all fit together, and that's important too. So yeah, I think it's this approach where there's no problems in there, but there's examples in there, and yeah, it's not like some homework to be doing type of thing. So it's like a mathematical adventure.
Oh,
So
that's cool.
yeah, it's kind of like going to be the new bestseller, I think. But
Yeah.
it's interesting because you write a book that it's taken me 5 years to get this far with, and I'm well into the second book and the third book too. But yeah, it's like you spend umpteen hours doing this, and it's a book that will sell no copies in a way, because everyone knows that once you put one equation in the book, your sales plummet by 90%. But the goal it's for the pure joy of knowing, and so that's what it's all about. And so I think it's like this thing that it's like a labor of love in that way. And yeah, I think it's just like as an author, you get so much out of it. And I think if I wasn't doing it, I wouldn't be the same person. I wouldn't be happy. I wouldn't be complete in that way. And I think there's that part that drives us all to kind of learn more in some regard. And I think it's just like don't deny it, just kind of just fulfill it in that way. And so that's kind of where I'm at right now with this project, I guess.
All right. Well, I mean, I'm glad to hear it, but now I'm interested in, like, okay, what is this? Like, if you can formulate it in words, what would you say your first off, does it, you gave it a name? Can you? What was the name again? The Greek.
For
Ari,
Arithmoi, the name of the book, you mean?
Arithmia, yeah. So Arithmia. So the name of the book. So would you, for all intents and purposes, call that your theory, or that's what it's called, Arithmia?
Yeah, I mean, it's just like it's kind of like paying homage to the Greeks and the Pythagoreans, who from what we know, historically, if you go back into history, saw reality for what it was. It's a mathematical construct, and all is number in that way. So I think it pays tribute to that. It has nothing to do with arithmetic from the Bible or the Book of Moses. It's, if anything, it's the antithesis to that in many ways. So it's basically it's the paying tribute to that and what they thought, and basically developing it to a level that's up to speed with where modern day mathematics and physics is. And it's a huge undertaking in some ways, but I think it is approachable now. And I think
So
it's
when you say it's an undertaking, what are you undertaking? Because we've talked about physics, mathematics,
mhm,
geometry. So
yeah,
is what you're doing with Arithmi, or in your book, is it connecting mathematics to geometry and then geometry to physics? Or if you can really zoom out and give like a quick statement as to what
sure.
it is that you do with your mathematics, what would it be?
Yeah. I mean, I think first, to see where physics is, they've come a long way in terms of using group theory, we call it, to describe forces. Like the standard model is based on groups, and so you'll hear different terms like U1, SU2, SU3. So those groups, they're generators, they're called, and basically generators are responsible for the forces that we see in physics. And so, but they, like, Gelman was the one who came up with the kind of quantum chromodynamics, which is just gluons and that form quarks and how they exchange gluons. And that group was SU3. But he kind of put together something that worked. And the problem with it, it was a nice development at the time, but they chose the particular form of the group because they only observed 8 gluons. But symmetrically, there's nine potential gluons, and so the issue is the last gluon is called the color singlet, and so this is a physics term, but it's like the one that kind of makes it whole in a way. So the color singlet actually exists in this light region that isn't accessible to experiment, and so it's basically corrects a lot of the things in physics that work for predicting things and things that are observed. But to be cohesive and to be whole, you have to be open to things that we will never be able to observe with the experiment. And so the groups are kind of put there because they seem to work. They treat light as only electromagnetic phenomenon, even though light is much more than that in how the book presents it. So, what we see as light in physical reality is just one entry in a matrix that's passing through, or are we passing through it, in space-time. But it's central and its core, and it's running on this axis that spins off numbers that actually form groups. I should define what a generator is.
Before you do that, I'm going to reiterate, because again, you get lost so fast. Like already, I know what gluons are, and I know how they can form quarks, and then but for anyone who has like zero knowledge, again, I'm always trying to bridge.
Sure.
So obviously, everything that you've said will have meaning to a lot of people like Alex and others, and so on. There would be a variable, like a variety of different levels of understanding. But if I can reiterate what you're saying, because my question was like, what does your mathematics do? Here's what I heard. I heard that there are things in physics, great timing. There are things in physics that so like you said, that can take you so far, and in terms of understanding a unified theory. And one of the mechanisms or vehicles that they've used is group theory, which is breaking things down into their categories. But that has certain limitations when you get down to it, which is the color singlet, as you said.
Yeah.
And then at that point, you can pick up the slack with mathematics. And so your mathematics picks up that slack and starts to describe a bit further. Is that
accurate? The starting point is like what the singularity would be and what it would be mathematically. The first priority is to it's to unify the geometry that they do use in physics. But through that process, you realize that there's the nothingness that some people say, the 0 point, that actually exists, and that explains the physics that they use. The interesting thing with groups is they're geometric. They're actually shapes moving, and that's basically what they boil down to in that way. Those are forces. Forces like at this level where they have a different type of rotation from what we're used to, where we turn on a two-dimensional axis when we turn this way to go there. So it's light doesn't turn like that. Einstein said light's a line; it travels in the path of a line, and which is kind of true. Where geometrically we talk about curvature, light's flat the way it spins, but it spins almost in 3 dimensions at once. And so, that's what it really is like in a simplified way. Light has this unique property where one part turns and the other part turns, and they turn together. And so it's almost like this axis that's turning in 2 different directions that keeps kind of manifesting as like physical realities and also other phenomena. So, that's what it actually looks at. So it's truly a theory of light. To get there, you have to unify geometries that they use in physics, because there's many different fields that they're pulling from, and they don't blend well in many ways. So so for instance, there's mathematically quaternions, which is Hamilton discovered those. He was an Irish physicist and mathematician. Then there's geometric algebra. They're pretty similar, but they're not quite the same. So you have someone writing a paper totally this way and someone writing one another way, but they seem to all come together, and they're from the source of what this mathematics is, and it uses matrix representation theory, but they all kind of come together. And so that's a priority to have it have wide impact. It unifies the quaternions with geometric algebra, all these different fields, and but it explains it in a way that makes sense. And so yeah, I mean, sorry for like
No, no,
going
not
off
at
on
all. But you can see why I'm holding your feet to the fire, right? Because
yeah,
as soon as you go off into tangents really easily, it gets so complex, and then you just get lost right away. So that's why I always try to reframe,
sure.
recontextualize, reiterate. And so, but at some point there, when I did that, you started explaining it in a way that's like, wow, that's interesting, that's fascinating to me.
Yeah.
And I'm starting to get a better picture a little bit now of how. Here's the way I see it. Now I'm thinking there's physics, there's theoretical physics, which is at like the very forefront of the whole field,
Hmm.
but they need to use mathematics. So like at the tip of theoretical physics, you have ontological mathematics. It's almost like I
Exactly.
didn't even know you could get even further than theoretical physics. I thought after theoretical physics you have metaphysics, philosophy, but no,
Yeah.
you have a whole mathematical ability to describe reality, and it to me, this is why I was like, okay, I need to speak to Alex. I need to speak to Jason, and like mathematicians are starting to pop out of the woodwork, and I'm like, okay, is there a way to now, as a metaphysician, can I understand the mathematics? Can there be some? Because the interesting thing is that a lot of course, empirical experience of just being conscious, thinking, of course, but also some ideas about physics, truths that we've proven empirically have helped me kind of develop an understanding of reality, or have influenced me. So now I'm thinking, well, how much more could I learn in mathematics? Certain ideas that if they're really broken down clearly, and that I can achieve a certain amount of complexity in the understanding
Mhm.
of those mathematics, how much of that can influence me in my philosophical work, so that I can actually boil it down in a linguistic manner that can get everyone to understand it. Like, you know, I think that's really what I want to do. That's my goal. But at the same time, I think if it's almost like a proof, if you will, if you're capable of doing that, of explaining certain mathematical truths to metaphysicians, and the metaphysicians can explain them in turn in a linguistic manner, and that it's rigorous. The logic is, you cannot, it does not falter in your logical reasoning of those mathematical truths. Then it seems to me like that is a good way to test your mathematics, right? It's not
Sure.
just peer reviewed by other mathematicians, it's understood logically by the layman. So to me, that is what a true theory, like unified theory, would be. It's so much more than just understanding. Would So I've said this in other interviews. I do believe that the singularity is not just a mathematical physics slash physical slash logical understanding. It would also be applicable. It would
Hmm.
be a technology.
Yeah.
So
Yeah.
and
I mean,
so
I
if
think, yeah, go
sorry.
ahead. Yeah, I think right now it's like physics does border on in many ways with
Mhm.
like space time and what they call virtual particles pop in and out of existence. That's coming from the singular source in that way. So they do see it manifest. And yeah, so
Mhm.
I think you're at that point where you can do it. And now with the race to develop quantum computing, yeah, just the for science and technology, there is application there. So
Mhm.
um, and so I'll from the quantum mechanics standpoint, or really quantum field theory, they'll use probabilities because they want to make something real that can be observed. But there's unobservables. So the mathematics there actually starts to go into the unobservables and potentially where they are. And so I think there's applications even to things like uncertainty and other
Mhm.
things that are in there. So it's you can you write thousands and thousands of pages on stuff that's related
Yeah.
to kind of what's there. But yeah, I think the prime objective is to describe the non-local mathematically with rigor in a way that's digestible, and to
There you
show that
go.
it goes down to actually geometry and shapes moving in space.
And then the geometry and the space, and it can be boiled down to a piece of language, and then the piece of language can be boiled down to, and that's the irony of it. Like, There's a guy, his name's Roy. He's a big part of this community. I've actually started my own, I call it unity theory. Um, well, of course, it's not mine. I do believe that there's a true unified theory, first off, would go on forever in a
Mhm.
way. It would continue to take on complexity and resolution. But at the same time, there is a constant there that would be completely simple and it would collapse. Everything, all that complexity that emerges collapses to the 0 point at all times, and you have to understand that. So this Roy, uh, he's brilliant because what he does is he explains mathematics in such a way that he proves that everything is, he says false. I don't think it's false. False doesn't really have, true and false has no meaning on the most fundamental level of reality. When you're starting to describe truth, you realize that it's, but what he's saying is that the way that we understand mathematics will generate complexities forever. You'll always have equations, like you said. We're trying to do things with rigor, but ultimately, if you're trying to describe what can't be observed,
Mhm.
well, if you're saying that mathematically you can describe it, then you are observing it in a certain manner. But
Exactly.
the question becomes, are you observing or creating?
Yeah,
Because
yeah. I mean, I think
consciousness.
that's a good point. Yeah, but yeah, and that's why it's important to show that this approach mathematically leads to the physics that's in the literature, and that's what's described. And there can't be any dancing around the subject. It's got to lead to it, and lead to it all in that way. So, and that's the importance of it. So, I think that the approach it's to unify physics. You unify the geometry that you're using to try to describe physics. It boils down to that, and that's a simplification, but it's really the essence of it. So yeah, so the book attempts to do that, and I think succeeds in that regard. And it's geometric. Geometric means mathematic to me. I think many people maybe might see it differently, but geometry is part of mathematics, and there is a part of mathematics called the Langlands program, which is higher level, but it actually shows they're all talking about the same thing in a way, where all these branches of mathematics that seem pretty disparate and disconnected, they're one and the same. And so there's that emphasis in the book also, where connecting things. That's a big simplification overall with mathematics and physics, and so I think it's really helpful. Where I think things are discovered, and then they kind of start looking at it, and then they develop a new branch of mathematics. But actually, it was just some offshoot from something they weren't seeing before from this other branch, and so it's just just making those connections to unify. That's unification
Yeah.
of any theory. And you're right, you said it before, a grand unifying theory must explain consciousness. And so
Yeah.
that's the end goal of the series. And the first step is you open the door to, there exists something that is outside of physical space-time that seems to cause physical space-time. That's the door you enter to start to explore origins of consciousness and mind and those other things. So
Yeah, but so that's why I find Roy's theory so interesting. He calls it non-conceptuality, because the moment that you do start to understand, whether through logic or experience, meditation, and so on, right? Like a lot of people don't realize that the Vedic texts, Hinduism, they consider these things sciences. The science of consciousness. You're observing. It's one moment. Excuse me. So it's kind of ironic how he turns it on its head. He says, well, if you're all about observation, why don't you observe the very thing that is making observations? That is the most rigorous way to do science and math. You observe how mathematics unfolds in your mind. You observe everything from a non-judgmental standpoint, and you start to realize that you're in fact creating, because if everything is consciousness, or if there is one underlying substrate, and it's an emergent phenomenon, then you are, logically speaking, it follows that you are creating You're not just now. Maybe it's both. Maybe it's paradox.
Yeah.
You're creating and discovering at the same time. That's why it takes what 300 pages to prove that 1 + 1 = 2. But at the same time, 1 + 1 = 2 is sufficient
Yeah.
because what's emergent is the one, and then you can go even further and just be quiet. So this is what I'm trying to do. It seems like we're all doing different things, and I think that I'm trying to understand how everything fits together always, right?
Sure.
Like you're trying to understand how, or you are unifying geometry, physics, and mathematics in a way, and all the different mathematical fields. But then I see that as nested within a logical sort of framework, and then
Yeah.
Roy, he sees all of it as just uh, all of it is always just emergent from the zero. We're calling it the superposition or the zero potential. That's the
Yeah.
way we sort of termed it. So that's what's interesting is to me the way that we've worked. So I'm kind of excited in this manner because if if we are logically understanding how consciousness can generate uh, a world, well, then the question becomes, okay, when it generates the world, what does that look like? And that's what ontological mathematics seems to be the next step. Is if you want to understand the actual mechanics of how consciousness can create, to
Mhm.
me, ontological mathematics seems like what that is, what it is doing. So, like,
Sure.
if you, I made a video with, it's called the triune system. We use again Roy's idea. He believes that duality. We have a bit of a tussle back and forth, but it's really just comes down to semantic difference. And at the end of the day, if you look at like triality, a triangle necessarily has its base. You can't get rid of duality.
Mhm.
Duality is nested within triality in a way. So uh, what my philosophy does is it uses duality in order to understand that synthesis, that third
Mhm.
aspect. And so if you create a triunistic sort of like chart, right? You
Mhm.
have the positive, the negative, and the neutral. And this is something that keeps emerging, by the way. This idea of a triune system. It's just in different ways. There's another philosopher who's also come up with a philosophy of paradoxism. Prior to me, I independently derived mine. His name is Smarandaci, Florentine Smarandaci. He has this whole new field of mathematics and logic, and it's amazing. All based on something he calls neutrosophy, and
Mhm.
that there is a, not a, and neutral a, which is a combination. It's almost like in quantum mechanics. You have probabilities. You have a mixture, an infinite mixture of the two. But it seems that we necessarily have to see things in a triunistic method in order to understand truth. But but of course that is composed of duality as well. So if you see in the zero column
Mhm.
that which we are trying to describe, it always sort of unfolds into a duality because we are beings of differentiation. We see things in terms of contrast. Mathematics is always two things. So, but ultimately, if you want to reunify everything, you want to collapse everything, you need to understand that those two things cancel out. Welcome to
Yeah.
mathematics, right?
Yeah.
So,
And I mean, yeah,
um,
that's the thing. We're talking about the same thing. What I call net zero is exactly
yeah,
what you're describing. And, historically, yin and yang, all those things, same
exactly.
thing. There's duality, but it's rooted in a common ground, which is the 0 point or zero, so to say. So we're
There it
talking
is.
about the same thing.
Look,
And I think when we realize that, that's how they connect, and that's how the fields, even though they seem quite different, they're one and the same. They're taking different approaches, but it's the same thing.
but and here's the beauty of it. So the idea that we all have access to the same reality is kind of the proof is in this very moment. I'm a high school dropout. Okay, I haven't even finished ninth grade, and
Yeah,
for me to be able to understand these ideas or at least arrive at these ideas on my own, it goes to show you that we truly do have access to the same reality. And if you have that assumption in hand, then ultimately you do believe that a unifying theory is possible. Um, and that almost everyone and everything fits into it. By definition, if we are all part of reality, then we all
Yeah.
have something to bring to the table, like you said. So this is why the triune system, the way that it works, if I can bring you into this a little bit, because I would be interested in seeing if there would be a way to work with you on that.
Mhm.
We start with the zero, but then we use a linguistic we make a leap, right? We do believe that consciousness is more fundamental. But ultimately, even consciousness is too far. You have the zero, and even that is too far. So there's Taoism, right? The Tao, the way.
Yeah.
The way that is the named the way is not the way. It's this idea that ultimate truth, you start to divorce yourself from it as soon as you speak, as soon as you start to have an idea. This is why Roy sits in his mansion and just doesn't do anything. He sits between two thoughts. But to me, the beauty of unifying theory is that it keeps integrating itself. It keeps on generating and integrating at the
Mhm.
same time. And it collapses at the same time. It's completely paradoxical to us. It generates forward and collapse in on itself at the same time, meaning that and here's what's interesting about this triune system is that what we did was we took a chart and we started plugging in dualities and
Mhm.
finding what that common neutral zero is. And of course, at some point, I think obviously mathematics has to go into one of those rows.
Yeah.
And ontological mathematics might be, and geometry and so on, and maybe even these rows, like you said, you have different fields of mathematics that open up, and this would be infinite. So these rows would also kind of multiply and go on forever. So there's a few people in this community that have what I call a spiralistic type of theory, which is the idea that. So I'll give you an example. Daniel Varga, he's a Hungarian philosopher, and he's working on something called jumping continuity theory, and I like to call it spiralism. But he sees things in terms of groups as well. And same thing with Tyler Goldstein, sentient singularity theory. They see things as groups. So they say they look at levels like the atom, and
Mhm.
then molecules, and so on and so forth, up to human beings, cities, and so on, planets. These groups, these patterns, they emerge and they have a number attached to them, of
Yeah.
course, which is like how many years does it take for these groups to form between
Mhm.
each, and so to me that will go on literally forever,
Yeah.
and and so um and between the question is there a between? Because if you look between a quark and an atom, like, is there a between? You look
Like,
between an atom and a molecule, is there an in between? And so mathematically speaking, I think that's the only way to understand how it smooths out in a way that there is no levels that jump. They do jump to our appearance, but maybe they don't jump. So anyway, you can see how this like multiplicity of infinities and of these jumps and these levels, these groups will go on forever. The question is, can we plug them into one system that allows people to see that it all can collapse and it will all continue to generate at the same time, so that those who want to continue to play within their fields, within their levels, they'll continue generating and discovering. And others will realize, well, that goes on forever, and they'll just stop and then just see that it can collapse. Either way, there's going to be this unification in the sense that we all have a grand view of what reality is doing.
yeah.
Does that make sense?
Yeah. I mean, I think it does with, it's just like mathematics and like quantum field theory. And everyone's heard maybe the wave function collapse, but it's basically what manifests to us as something observed or something real. But that's the thing where it's collapsing, but then it's off again in a way where it's that doesn't mean that the form of it has gone away. It continues, but it's almost like it's pinging our perception of reality, but it's still moving. And so yeah, like the book explains about light, and I'll try to be much better at instead of
Yeah.
blabbering on about it. But we kind of move, like we go in a direction, and light operates almost like it's like to that to the power of how we move, and so that means that if you have a function that's has, like, say my function of movement is f of x, and so x is like which direction I'm moving, forward or backward.
Yeah.
Light actually is multiplying that x in that way, so it's a little hard to explain, but that's why it seems we can perceive it in many ways, but we can't. It's almost like we can't relate to it at its most fundamental level by an approach that's kind of how
Mhm.
we've done it before. So
Yeah.
it's kind of the duality where it's rotating one way and it's rotating the other way all at once, and that comes together to spin about an axis, and to make things kind of possible in terms of existence forming to begin with. To be
Mhm.
here to talk to you today about it. But
Exactly.
yeah.
So my
So
question to you then would be, does that so can mathematics help us relate to all these things that I kind of brought out of nowhere, that these things that we don't understand, how there can be infinities between infinities, or levels between the levels that we can perceive, and it goes on forever. Is there a mathematical description of that?
yeah, I think so. I think like everything that you were saying was kind of jiving with what like is there mathematically and in the book, and there's so many parallels that you're describing, and I
Yeah.
think it's like when you have that, it's not just coincidence. It's we're onto the same thing. Maybe the approach is different in some way based on
Mhm.
presentation, and but yeah, it's we're after the same thing in a way, and this book is a mathematical approach where it's nice where it leads to other avenues and opens doors to actually describe, if you enter that door, what's the room going to look like,
Yeah.
mathematically. And so, and that's kind of how we, hopefully can make progress with it, and really get tangible results through these investigations of it in that way. So, and I think it's, like you said, it's the synergy between, we feel pain, we feel heat, cold, or hungry, but then there's this other part of us that's the thinking part of us, and so we exist in a dual form in that way. But
Mhm.
we're grounded in the commonality of zero. In group theory, it's really one in a way, where it's more like the volume
Yeah.
of the 0 point. But yeah, it all comes back to that. So
Okay, so see, like this is where, so I'm gonna have to start winding everything down and head out in a few minutes. But this is why, like today, I just wanted to get a bit of a big picture view, that perhaps in the future we can start digging into some of these things that you're saying, to accurately describe how everything functions mathematically, and then relate it to the zero, and we can start to see how all these fields relate to zero. But so, like for example, here for anyone watching, this is one of the things that you're working on, and I want us to dive into the visualize it. Like everything we've discussed is quite abstract, but if we start to visualize, like you said, it ends
sure,
up being a lot more
yeah,
it ends up
tangible, yeah.
tangible, and I think that's important. So, what I would like us to do, if you're willing in the future, is to start with. Obviously, we can't start to. You can't lecture me on all the mathematics so I can understand
Mhm.
exactly, but there might be a way for us to go on certain levels, right,
Sure,
and just
yeah.
understand to a
Speak
certain
the same
degree.
language, yeah.
Exactly. So, like you said, for example, I think we would have to start with what is a superposition.
Hmm. Sure. Yeah,
You know,
superpositioning is just laying one thing on top of another, and they add together, and then they can expand, but they can also negate. So yeah, that's what it is.
what does that mean, right? Like, for
Yeah.
example, is is zero a is zero one, or is it? See, that's the thing. Is a superposition two? like two aspects of one thing, or it's the very philosophical aspect,
Sure.
right? Like,
Sure.
but that is at the same time the beginning of mathematics.
Yeah.
So is to understand the connection between 0 and 1. Is 0 just the negation of itself, or how do we begin to understand the very root of mathematics, which Roy would say is just we don't. We begin to make mistakes, and then
Yeah.
ultimately, and that's kind of true in a way, but at the same time, it's not a mistake because here we are speaking and here we are using mathematics and there's utility and the
Mhm.
world exists. So it's not necessarily a mistake insofar as it's only a mistake if your view of the world is to stop understanding it or is to stop suffering, which is
Yeah.
his view. But if you realize that reality generates regardless,
Yeah.
then these numbers, this string of numbers, isn't a mistake. It depends on the perspective that you take. So next time it would be great if we could discuss that and then lead us. We could maybe lead in further into your book and into
Sure.
the core aspects of your mathematics.
Of course,
Yeah,
that sounds great. Yeah. Yeah. I think it's yeah, this stuff where yeah, it's just like speaking in common terms or like agreed upon way. It's important to kind of bridge to one another and kind of the work that you guys are doing and the work that we're doing as well. So yeah,
yeah,
and one and zero, yeah, or infinity, yeah, it's they're there are a lot of interconnections there, and yeah, just just with the singularity, there's always a connection between the singularity and the physical thing that it manifests. So it's not broken. So yeah, I think there's a lot of neat stuff there to look at, and it's fulfilling in the sense from the intellectual standpoint, but it's fulfilling from the sense of like a kind of a deeper, more fundamental logos and spiritual standpoint. Some people would say so. Yeah, I think it's just a good thing in that regard too. So, but yeah, I'm happy to come back on anytime. And yeah, so now we've got to finish a few edits, get the book out there, and
mhm,
then sleep in a couple days, and then
yeah.
start working to finish the second one. So.
Wow, that's incredible. You said it took you 5 years, and when is it coming out?
I think it's written. We're just I'm just doing a little bit of editing. I have a friend in Quebec who's helping out with some of the edits also. So it's math is like this odd thing where it's like you always feel like, man, did I do something wrong? And so I think
Mhm.
it's one of these things where you want to try to perfect it, but I'm prone to human error, and so is everyone else. And so it takes a lot more time and effort and going
Yeah.
over it to do it. And yeah, I think
Mm, when you're
like
dealing with infinity as well, the probability is you will be wrong somewhere. I mean,
yeah, yeah, and
it's
I'll
tough
be the
stuff.
first to admit it. And
Mhm.
but I think overall, you take the perspective. If someone sees something that's an error, they say it, and yeah, you want to make something that's the as perfect as possible,
Yeah,
if possible. But yeah, so I think it's like a thing where you release it into the wild, and then hopefully it takes off and people contribute to it, and then you have a movement in that way.
yeah.
So yeah, that's kind of what it boils down to.
But I think there's value there too because, somehow new errors can be discovered and you realize I didn't, that if you discover that there's new possibilities for errors to occur, then
Yeah,
there's, in a way, it is driving you closer to truth.
yeah.
Um,
And
so
error's not necessarily a bad thing if you learn something
no,
from it. And I think
exactly.
mathematically, I make the joke, I take the path of most resistance. And so that means like ignoring the reductionist approach and just
Yeah,
expanding everything and getting lost in the numbers. But that's how you connect patterns. And I
yeah.
think it's like to fundamentally learn math and its patterns, or logic and its patterns. You gotta
Woo!
bust it out and start playing
Oh,
with it. Yeah.
Jason, it all just came to me now. I understand what you have in the same spirit of a metaphysician. You've unchained yourself from all orthodoxy, and you're just floating around. Like
Oh
You
yeah,
are
yeah. I'm
creating
just like
mathematics.
floating by, so people have to grab my cord to keep me grounded, man. So it's
Yeah,
kind of a
yeah,
joke, but it's a little bit true. Like, that's
yeah,
why the Mikel in Quebec, he works well because he's well rooted, and I'm just floating around somewhere. But
yeah,
sometimes it takes that duality to put something out that's tangible and meaningful. And yeah, so it's I think there's partnerships that have happened in the past with great science and logic that someone was the one that was putting the words that made sense together just to explain the idea and things. But yeah, I
yeah.
think it's almost like,
Ramanujan,
yeah, you have
Ramanujan, for example. You
exactly,
know,
yeah. When he saw
he
Hardy, and Hardy's like, dude, you got to prove this. I know it's true though. And then
yeah,
so yeah,
yeah,
it's like that's an awesome story about that. But yeah, it's like you have to have a balance in a way where it is a synthesis of idea, form, and presentation. And yeah,
yeah,
sometimes it's hard. I love the form and the idea, and presenting it is the thing that's difficult. So that's editing in this regard. So it's not
yeah,
as fun for me, but for some others, they love it. But yeah, so I think it's just like bringing it all together in that regard to do something that has an impact in a way that is meaningful for people. So and for like advancing human knowledge and kind of reconnecting humans with their kind of consciousness in a way that they know that they can stop worrying about death and dying in a way when they know something else is there that made this possible to begin with. So I think it introduces a lot of ability to put people at ease in some ways in that regard. So yeah, the math has meaning. It's scientific, but it's more than that. And a lot of metaphysics, same thing. It's same thing. We're doing a little bit different approach with showing it in its mathematical terms. But it's
yeah.
yeah, it's like it's the great work in that way.
Man, well, Jason, I have to thank you for like really sort of massaging it and starting to because unification is communication,
Mhm.
in a way. And
Yeah,
for you to come on and communicate with me and to take part in this community and to allow the ideas to be free flowing, I do think we're in a sort of renaissance of enlightenment period.
yeah,
As both there's like a new enlightenment period, where people are starting to come together. They're not afraid to discuss ideas to go against the grain, and that prestige isn't separating us anymore. We're really trying to come together and see what can emerge when things happen like that, instead of just staying in our zone, staying in our categories. So you're speaking to me, a non-academic philosopher, weird
yeah.
dude, but
No,
you
no,
know,
that's who I like. Yeah, just
yeah,
yeah, I think that if too
yeah,
rigorous and too dry, I'm asleep. Yeah, so I think
yeah,
it's good. And I mean, honestly, it's like you shouldn't be judged by what your education was. It's what you've done to learn. That's what it's about. And so I think it's just
yeah,
like yeah, I think people are realizing that the paper degree, at least in here in the United States, is so
yeah,
expensive, and what do you get from it? It's just like just something you need in your pocket to get a job. No, it's
mhm,
life. Learning should be like a lifelong endeavor, and the folks that do that, it's not dependent on, if you left school at ninth grade. It's like lifelong learning is a thing where it's ever changing and dynamic, and yeah, it's like there's no comparison between someone who got a university degree
well,
and
I think it's. I mean, I'm going to play devil's advocate, because everything you're saying, I normally would make the
mhm,
same case. Like, hey, look, with the internet nowadays, you can educate yourself, and
yeah,
academia is big bad academia. But at the same time, there is value in it historically. I think, like, it shows that you've put dedication and time. That is one thing that I
yeah,
really admire about people like yourself that hold PhDs. It's like, man, you dedicated 6 to 8 to 12 years of your life, depending on what field you're in,
yeah,
just to understand this one specific field. Like, that is, it
yeah,
shows rigor, it shows dedication, it shows and I can understand why a lot of academics kind of look down on people who are just field jumping and going
mhm,
nuts and making statements that they're like, well, that's not you kind of, I think a lot of academics would see that as being like a dilution of
Yeah.
education. But I think that the two have their place, and it's nice for there to be a balance to emerge when two people from those worlds come together like we have. And again, I want to thank you so much for your time. We're coming
Sure.
up on 2 hours. It
Pleasure to
was
be here.
fantastic.
Yeah.
I could go on for another 4 because we haven't even discussed your
Yeah.
ideas really, and I want
So
to,
yeah, it's
you know,
yeah, that's it. It's just like, yeah, if I was done in 5 minutes, maybe there's not too much to this book, but I can
yeah,
talk for days, and but happy to come on any other time. And for now, we'll just get the first book out and keep working. And
I
yeah, it's just
agree.
thanks for a platform just to discuss it. And yeah, just yeah, anything about the the triune stuff that you're working on, happy to give input for that too. So
Oh, that's fantastic. I'd love it. Maybe we could do next time at some point three-way chat with Alex as well. I think that'd be fun.
yeah, that'd be great.
Right.
Yeah, yeah.
And
So
once the book that you get, anyone who's still watching here, the link will eventually be in the description for your book, and anywhere else. If you have a website, just send me that over on WhatsApp there. Thanks to
sure,
everyone for listening. Again, Jason, I really appreciate it, and
yeah,
we'll see each other on the next one.
perfect. Yep. Take care, everyone.